So this is lesson number 74, uniform motion with both distances given. Okay, so far we've done 3 different types of story problems dealing with the formula distance equals rate times time. Okay, we've done this one here where we're given a distance this way and it equals the distance this way. So maybe you rode your bike to McDonald's and walked home. So the distances were the same, but maybe your speeds were different. So if the distances are equal, the RTs are equal, and that's why they have them written here. The other type you did is you started here, and your buddy rode his bike this way to Kenai, and you rode your bike to Cooper Landing. And then when you stopped, your distances were 120 miles apart or whatever. So the distance that one person rode plus the distance this one rode gave you a total, which again, since distance equals RT, rate times time, we can say that the rate times time of one distance plus the rate times time of the other is going to be your total distance you are away from each other. And the third one that we did said that maybe you started here and you went this far, and your buddy started here and he went this far, and when you both stopped, you were 40 miles away from each other. So if you took your distance plus 40, that would equal his total distance. So the rate times time of you plus 40 is going to equal the rate times time of your buddy here who went RT. Okay, so in this one here, I'm going to add a new tweak to it. So I'm going to give you the distances of each object. So, and they're going to be I don't know if they'll be the same through the whole thing or not. We'll have to try some and see what happens. Alright, so remember, distance equals RT. Very important for this. Okay, so, example. Friar Tuck rode 24 miles to the fair. Okay, so his distance going was 24 miles. When he turned around and came back, his distance back was also 24 miles. The difference is that the speed that he went was different and the time that it took him was different. Alright, so it was 24 miles there, 24 miles back. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. His total traveling time was 9 hours. How fast did he go? Alright, so if we take the rate going times the time going, which is distance, that equals 24. His rate back times his time back was also 24. But look what we've got here. We have 4 different variables there and how many equations? I have 2 equations. One here and one here. So in order to solve this, we have to have 2 more equations. So if you have 4 variables, you have to have 4 equations. 3 variables, 3 equations, etc. So where are we going to get our other 2 equations? Well, we can get them from the problem. He stayed too long at the fair and had to go twice as fast on his way back. So his speed coming back was twice his speed going. Okay, so there's an equation. And what else do we know? His total traveling time. If we took his time going plus his time coming back, the total traveling time was 9 hours. So there are our 4 equations there. So let's see, what are we going to do with those? We're going to start substituting here, just like you did in some of your other equations, in order to find that. So we're going to use a base equation, and this particular one we'll use that is our base equation. Let's see, so instead of let's use the base equation the book gave. The book used this one as their base equation. You can use either one, but let's just stick with what the book's doing. So if that is our base equation, our RB will now be 2RG from this formula. And we have as our TB, we've got something right here, and we can rewrite our TB as TB equals 9 minus TG. and we'll put that right here, and that equals our 24. Alright, so let's move that up. What do I have? Distribute. Now, do we have anything that equals RG and TG? Let's look back up here and see. Yes, we do. Right here, we said that RG and TG is 24, so I'm going to replace that with a 24. And then when you do your math, your RG is going to turn out to be 4. So that's how fast he went. Okay, so then I just take this answer, plug it into some of my other equations up there to find out how fast it took him to go back. What all are they asking for? How fast did he travel in each direction? So they want the speed in both, and then they want to know how much time it took him. Okay, and you'll use, again, your equations that you have up here, plug things in, and you end up getting a time of 6 hours and 3 hours. Okay, so let's look at one more example. And I'm assuming you're good enough in algebra you can do the rest of the work for that. You don't need to have me take you through how to do the simple algebra. Okay, so Atalanta ran 4 times as fast as her challenger. In fact, she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. How fast did each of them run, and how long did they run? So the distance Atalanta ran was 80 miles. And the distance her challenger ran was 28 miles. Okay, so the distances are different. So her rate times time equals 80. And her rate times time equals 28. Okay, so there we have 4 variables and 2 problems, so we need to come up with a couple more problems. Alright, so what else do we know? The time that Atalanta ran was 2 hours less than her challenger. So the time of her challenger minus 2. Okay, so that would be another equation. The speed of Atalanta is, it says that she ran 4 times as fast. Okay, oops, not R, A, R, C. Okay, so there's my 4 equations. So let's move these guys up, and we're just concerned with our equations there. And we will use as our base equation, pretty much any ones you want, but let's use these 2 and see what we've got. RA, we're going to substitute 4RC for that from this equation. And TA, we're going to substitute that for it. Now notice, I substituted. Now I have an RC and a TC. Okay, and when I distribute, I'm going to get an RC TC, which up here is 28. So just that, looking ahead a little bit. RC TC is 28. And we just got rid of 2 variables. So now we're down to 1 variable there. So 4 times 28, and then subtract that from 80, and then divide by the -8 there, and we end up with our RC being 4 miles per hour. So that's our RC. So then I can take that 4 miles per hour, put in here, and find out my RA is 16. And then I can take my RC, which is 4, TC equals 28, and divide and get that to be my TC being 7. Put 7 here, 7 minus 2 is 5, so my T of A is 5. So I found all 4 variables really quick and easy. So not too bad. The key thing, again, is knowing which one to use as your base number. And I would use one of the two that you're given clear at the beginning. And then you'll substitute this information into that base equation so that you can actually solve for one of the variables. Now if it doesn't work the first time, try something else and see if it works the second time. Okay, and that's it for lesson number 74.